All right, so here we are, module 9.1 again, day 2. We're still adding and subtracting rational expressions. So remember finding the LCD from yesterday. You have to factor your denominators, and then we want one of each. Since the x minus 3 shows up twice, we actually need it twice in our LCD. We're going to use this idea to add and subtract our rational expressions. So we're going to kind of jump in, and we're going to go over here to our adding and subtracting. We're going to do one adding, one subtracting, and we'll practice more tomorrow in class. So identify any excluded values and simplify your answer. So the first thing we have to do is make sure everything is factored completely. So on the numerator, we're going to leave it alone. We only care about factoring that denominator. And over here, we factor out an x, so we get x plus 1. Now, our LCD is x, and an x plus 1, kind of one of everything. So we need to change it so that this is our new denominator. So we're going to look here. I have an x squared plus 4x plus 2. I have xx. What is this one missing that this one has? Well, it's missing that x plus 1. So we have to multiply the same thing to the numerator. Because remember, to keep our fractions balanced, we have to multiply top and bottom by the same. Over here, this numerator has x squared. It already has 1x and an x plus 1. So it's only missing an extra x. So whatever I do the denominator, must do the numerator. Now, we actually do need to multiply things out. When I distribute this thing, I get x cubed plus 4x squared plus 2x plus x squared plus 4x plus 2 all over, and remember, this is right here, that's just x squared. So I get x cubed. We'll just actually, let's leave this as this for right this moment. Over here, I have x cubed, I have an x, and an x plus 1. Now, the denominators are now the same. That's why I didn't want to change it. You can look at them, they're now the same. So now we have to add the numerators together. Just like regular fractions. You change them so they have the same denominator, but you only really add the numerators. So I'm going to move that right over here. I have an x cubed plus an x cubed. That's 2x cubed. Here I have a 4x squared plus x squared. That's 5x squared. 2x plus 4x is 6x. I have that lonesome 2 that's on the bottom. And then I have x times x plus 1. Now, it says to simplify your answer. So we do want to make sure, can I cancel anything? Can I factor any common factors? Doesn't look like it. Can't do anything by grouping. So I'm going to go ahead and rewrite that numerator as x cubed plus x squared. Remember, it was x times x plus 1. That's x squared times x plus 1. Distribute it through, and you get here. Now, it talks about excluded values, which means we want to go back to its factored form. We cannot have our denominator be 0. So our excluded values, x can be anything it wants to be, except it can't be 0, because if x is 0, if I multiply by 0, my whole denominator is wiped out. And x cannot be negative 1. Because again, if this is negative 1, that gives me 0, my denominator is completely wiped out. So let's look at one where it's subtracting. Subtracting can be a little bit trickier, but it's done the same way. So first things first, let's get these denominators factored. Over here, I have an x squared plus 3x minus 4 over x times x. So looking at my LCD, I need one of everything. And I'm going to change my denominators. So the numerator is 2x. I want the denominator now to be this. This is what the old denominator was. So it's missing an x. So I need to multiply the numerator and the denominator by that x. Simplify it. 2x squared times x, that's 2x cubed. On the bottom, I have an x times x minus 5. Likewise, this is a minus. Here, I need x times x. So it's missing the x minus 5. So I multiply that to the numerator and the denominator. And yeah, I have to distribute that through. When I do that, I get x cubed plus 3x squared minus 4x, negative 5x squared minus 15x, and a plus 20. Denominator x times x minus 5. And we are subtracting. The tricky thing with subtraction, I would actually simplify this numerator first. So we have a 2x cubed, bottom x times x minus 5. Here, that's an x cubed. 3x squared minus 5x squared is a negative 2x. Negative 4x minus 15x is minus 19x. Plus 20 on the bottom x minus 5. Now, when you subtract, you cannot just subtract this. You actually have to change the sign all the way through. So I want to show you what that looks like as a whole. So I'm going to write it, unlike with the adding, as one big denominator. So I have a 2x cubed minus x cubed. The negative 2x squared becomes a positive 2x squared. The negative 19x becomes a positive 19x, and then positive 20 becomes a negative 20. Clean it up a little bit, subtract these, that gives me x cubed plus 2x squared plus 19x minus 20 over, remember that's really x squared, distribute your x squared, so it's x cubed minus 5x squared. The book asks you to simplify it, that is simplified. I actually personally think the denominator written out this way is easier, but we still need to list our excluded values. X cannot equal 0, and if x is 5, we get 0 there. So excluded values. A lot of times you'll see them written not as excluded values, but maybe as restrictions. We'll practice more